All right, welcome back to 12.3 areas of triangles, and we're getting started with 3 explorations. So pause here, take your time, don't skip these. These are going to help you make sense of the formula. Press play when you're ready to move on to part 2. Don't skip these, they're not the same. Really spend some time, and then press play when you're ready to go to part 3. This one is very challenging. Don't give up, just try. There's no harm in trying. We're going to make sense of this together, but just try it, play with it, have some fun, and then press play when you're ready to move on. So why is the area formula for triangles valid? Okay, suppose we have a triangle, and suppose we have a chosen base B and a height h for the triangle. Why is the area equal to 1/2 the base times the height? Now, in some cases, we can see that these are 2 copies of the triangle can be subdivided and recombined without overlapping to form a B by H rectangle. Let's look here. So we're basically copying this. We're saying, hey, let's just do 2 of these guys and let's put it on top, and we create a B by H rectangle. And so the area of my original shaded triangle is 1/2 of that rectangle. Well, we can also do the same thing even if it's not a right triangle. We can make a copy, but this time we're going to cut it into pieces, and I'm going to take this little piece here and I'm going to put it right there, and I'm going to take this piece there and put it right there, and I'm still getting, if this is H, then so is that, and I'm still getting a B by H rectangle. And so this little piece, that's 1/2, so this is 1/2 of that rectangle. Well, it can get a little more complicated. So what about something that we had to extend, right? So now our little triangle is not actually a part of the triangle itself, right? This little triangle was a part of it. So what about in this case? So it may not be super clear, but we can still use it. So to explain this, we're going to enclose the triangle in a rectangle. So we're looking at this here. We're enclosing this triangle into a rectangle. And this was that challenge part 3 if you tried it. And okay, so where are we at? Okay, so to explain, enclosed triangle. Okay, now the rectangle consists of 2 copies of the original triangle. So here is our original triangle, and we've got 2 copies of it. 1, 2. And then we have 2 copies of another triangle, this little extra base height triangle, right? And those are lightly shaded. Now this whole rectangle has an area, and they just named this little piece here. They kind of called this little piece A. And so this whole triangle, this whole length here is B plus A, or A plus B, but we could say B plus A times H, right? Just length times width. So when we multiply B plus A times H, if we distribute that, we get B times H plus A times H. So that is the area of this giant rectangle. So if we put the 2 lightly shaded triangles together, they form their own little rectangle, A times H, and that has an area of A times H. Now, if we take this away, we want to take this away, these 2 pieces, we would take our B times H plus A times H, our giant rectangle. We would take away our 2 lightly shaded triangles, which are a rectangle there, and we end up with B times H. But remember, this is B times H, but this is double what we want. We want 1/2 of this. We want just 1 triangle, and that's how we end up with 1/2 base times height. So let's do an example here. It says, explain clearly in your own words why the triangles have an area of 1/2 base times height for the given choice of B and H. All right, so right here with this triangle, well, I can see that I can just extend this into a rectangle. And so this is a rectangle, B times H, and the triangle is covering 1/2 of that. Let's look at this one. Now, there's a couple different ways I could do this, but I'm going to enclose this into a rectangle. And then I'm going to look at this as, okay, this is the rectangle, B times H, And then I'm just going to kind of look at this in pieces. Okay, this piece here, my shaded part is covering half of this rectangle piece. And over here, this shaded part, this is also covering half. So altogether, this triangle is covering half of the area. So my triangle is 1/2 base times height. Determine the area of the shaded shape in 2 different ways. The entire figure consists of 2 8-unit by 8-unit squares. All right, so let's look at this. What they're telling me here is that this is an 8-unit by 8-unit square. And the only reason why I have it twice is so I can write on 2 different ones. And so if this is 5, then I know that this little piece here, it's got to be 8 in total, so that's got to be 3. So here I'm going to look at this as, I'm going to look at my triangle. So let's say I call this the base. This is going to be the base of my triangle. And so if this is the base, then I need to connect to this here. So my height is right there. So I've got 2 triangles with a base of 3. Here's one triangle. Here's the second one. I'll use A and B. With a base of 3 and a height of 8. So that is 2 triangles with area 1/2 base times height. So that is half of 24, so 12. So 2 of those. So I've got 24 square units. That is the area of those 2 triangles. Now, what if I want to look at this a little differently? What if I want to look at this as a big rectangle? Well, I know that this is 8. And so if that's 8 and that's 8, then this whole side is 16. So this is a rectangle of 8 times 16 minus the unshaded triangles. So now we've got to kind of look at this a little differently. I'm talking about these. We're taking away all this white space. And I wish that it wasn't, I want a different color. Here we go. We're taking away these. We want to just be left with the shaded parts. Okay, so let's look at this. Let's look at this triangle here. Well, let's make this the base. And so the height would be up here and the connect it there. So there are 2 of these that are the same. So the unshaded triangle, we've got 2 that are 1/2 times base times height, 1/2 base times height. And we have another one. So we've got 8 times 16 minus 2 times 1/2 times 8 times 8. And we need to take away another triangle. These here, let's look. Well, let's make this a base of 5, right? So here's a vertex. Vertex, we need to connect here. So my height here is 8. So we need to get rid of 2, right? C and D. 2, 1/2, base is 5, height is 8. 2 of those. So that's going to be 128 minus, well, the 2 and the 1/2 cancel, so we get 64, and the 2 and the 1/2 cancel, we get 40, and voila, we still get 24 square units, which is good because we should get the same area both times. Okay, let's look at another example. Determine the area of the shaded triangle that is inside. Explain your reasoning. All right, so I'm going to look at this as a big triangle. I'm sorry, a big square, rectangle. I'm not sure if it's a square. No, it's not a square because those side lengths are not equal. And then I'm going to subtract the unshaded pieces. Let's call this A, B, and C. So I want to take the rectangle. So my total rectangle is 6 by 7. So it's 42 square units. And I want to take away the unshaded parts. So let's get A, B, and C. So A, what's here? So let's call this my base. My base is 3. So I need to connect to the vertex that's not on my base. So that's this. So my height is 5. So it's going to be 1/2 3 times 5. That's going to be 7.5, half of 15. Now, let's call this my base. We know that that's 6. So the vertex not on this triangle is this guy, so my height is 2. So that's 1/2 base times height. 1/2 of 12 is 6. Let's just write square units. Let's not get lazy there. And then finally here, I'm going to call this guy my base, which means that my height is going to be 7. So 1/2 base times height, half of 21 is 10.5. So the area of my shaded rectangle is going to be 42 minus 7.5 minus 6 minus 10.5. I'm going to end up with 18 if I can read my handwriting, 18 square units. You know, I'm going to type that in my calculator because I can't read my handwriting. 42 minus 7.5 minus 6 minus 10.5 is 18 square units. And our last example together before the U tries. The owner of an ice cream shop is making signs to advertise. Each sign will be in the shape of a triangle to represent a cone. The sides of the triangle are 51, 51, and 48. So I know 51, 51, it's isosceles, but it looks like this maybe. The height from the shortest side, okay, here's my shortest side, to the opposite vertex is 45 centimeters. Okay, so the height from here to here, forgive me, the height from here to here is 45. So what is the area of one sign? Well, the area is going to be 1/2, and if we call this our base, we know our height, so we are going to call that our base. 48 times 45, we're going to get 1080 square centimeters. And how much material for 4 dozen? Well, 4 dozen is 4 times 12. That's 48. So we're going to take this number and we're going to multiply it by 48. We're going to get 51,840. Go ahead and try these problems. Take your time. Press play when you're ready to see the solution. And that concludes this section.